In the second example, we look at a computer access password consists of from 1 to 3 uppercase letters. Of course, we kind of like create a hypothetical simple scenario. In real life, your password will not be that simple, right? But we are gonna just for practice purpose. So let's just say 1 to 3 upper letter cases. How many different passwords are possible? So now we are gonna divide all the possible passwords into the following subsets. The first subset is, what about it just contains one letter, all the different passwords, only one letter. The second possibility, the second subset will be 2 letters, right? And similarly 3 letters. Those are the 3 possibilities, 3 possible subsets, and they're mutually disjunct because one letter, it won't be under the 2 letters set, so therefore they're mutually disjunct. And then we just need to count how many possible passwords in each one of those subsets, and then we add them to find the total number of passwords. So for one letter, because we have only 26 letters, so therefore there were 26 possible passwords there. And for 2 letters, so let's count 2 letters, because we did not even mention whether they are like repetition allowed or not allowed. So therefore allow repetition, right? There's no restriction. So therefore 26 letters we can choose from to fill in the first one. So 26 times, similarly, 26 ways to fill in the second the second position. So 26 times 26. And for 3 letters, you just 26 ways to fill in the first one, second one, and the third one. So therefore the total will be 26 plus 26 square plus 26 cubed equals, okay? You can certainly just like find each one of those and add them together, but now I would like to kind of like review the sum of the first n terms of a geometric sequence. So like if you have a plus ar plus ar squared plus and so on and so forth plus ar to the n. So usually the way I see it, I would usually like to factor out the a, then it becomes a plus r squared and plus r to the n. And a times, okay, here's the formula for this part. It's going to be 1 minus r to the n plus 1. So this power is 1 higher than the power, the highest power in this part, divided by 1 minus r. Okay, so in this case, I'll definitely factor out my 26. It becomes 1 plus 26 plus 26 squared. And then this is equal to 26 times, there's a 1 minus 26 to the, this is 2, so it's going to be 3, 1 more than that, over 1 minus 26. And you can do the algebra. I believe it is 18,278. Okay, you can double check that. Now, the second part is how many different passwords that are possible with no repeated letters. No repeated letters. So we still look at 3 cases. One is the first first set is just 1 letter password. Second set is like 2 letter password. And then the third set is 3 letters password, right? So the first one is, well, only 1 letter, 26 ways. The second one, because we do not allow repetition, so 26 ways to fill in the first letter, first position. Once that letter is used, you're left with 25 letters, right? So times 25 only. And then plus, when you have 3 letters scenario, 26 times 24 times 25 times 24. All right, which gives you, I believe it gives me 16,276. 276. All right, this is example number 2. Let's continue the example number 3 in the same video. How many integers from 1 through 999 do not have any repeated digits? All right, repeated digits. Again, the way I will approach this one, I'm going to think about, hey, how do I divide these integers into subsets, right? So I'm going to divide these integers into single digits, double digits, and 3 digits. So let's look at those. So single digit. So single digits. And one is like 2 digits and 3 digit scenario. Single digits, because we start from 1 to 1, it's not 0. So therefore only 9 possible numbers, right? And there's, because it's single digits, you don't have any repeated digits. So just 9 numbers. And the 2 digits, so the 2 digits, think about this. For the first, you have to, the order is a little tricky. You have to first fill in the first one, the 10th digit. The 10th digit cannot be 0, otherwise it becomes a single digit. So therefore, I have only 1 to 9 to choose from. So there were 9 ways to do that, right? 9, choose 1. And because it's not repeated, the digit is not repeated, so 1 digit is chosen, and then we are left with 9 digits to choose from, including 0, because 0 is included here. So therefore, the second one will be 9, choose 1 as well. And similarly, for the 3 digits one, the hundredth digit here, 0 cannot be chosen, so 1 to 9, you choose 1, so which is 9, choose 1. So once number is chosen for the second and the third digits, there's no really restriction, except you cannot choose the one that's already chosen. So you have 9 digits left because there's a 0 there. So 9, choose 1. The very last one, because there are 2 digits are already used. You have only 8 digits left. So 8, choose 1, right? So you have 9 plus 9 times 9 is 81, plus 9 times 9 times 8, which is 648. That gives you 738.